Okay, so part L is using table J to figure out who gets oxidized and who gets reduced. We have been figuring out who gets oxidized, who gets reduced, using like little charges, oxidation numbers. There's also this table J. So if you look over here, this is table J. And if you look at what it says, at the top it says most active metals and nonmetals, most active. And the bottom it says least active. So it's literally just a chart of metals and nonmetals in order from who's like the most really reactive to who is the least reactive. And we have looked at this before, but you'll notice at the bottom who's the least reactive. Copper, silver, and gold, the things that we make jewelry and like pipes and like electrical. We use copper for like electrical wires. So there's a reason we choose those, is because they're really unreactive, right? You don't want your jewelry reacting with your skin and everything that comes across your hands, and you don't want your copper electrical wires reacting with everything. So we picked the least reactive metals for those. And then at the top are the most reactive things. Okay, so we can actually use this chart to figure out who gets oxidized and who gets reduced. So the rule is the one that is higher on the chart. If you were like, okay, I'm going to react lithium with aluminum, who gets oxidized, who gets reduced. So the rule is the higher one gets oxidized, the lower one gets reduced. So you could think of it in alphabetical order. It goes oxidized to reduced. Or you can think, okay, the richer, higher one gives electrons down to the poorer one, right? The rich give to the poor. However you want to remember it, the higher one gets oxidized, the lower one gets reduced. The higher one gives electrons to the lower one. That makes the higher one anox, the anode, and the lower one red cat, the cathode. So it goes also alphabetical, anode to cathode. So the higher one gets oxidized, the anode, the lower one gets reduced, is the cathode. The higher one gives its electrons to the poor, the lower one. So you might be like, well, why does the one that's higher and stronger do the giving away? What I'd say is the most reactive metals are the ones that are like dying to give their electrons away. Like they're really going to react because they're like, here, take my electrons. Same thing with like the strongest acids, the ones that really, really burn you. They're actually like really weakly held together. They're the ones that are like, here, take my H's. And then the H's go and like destroy your skin. So really reactive things are like really ready to like fall apart and give you their stuff. Anyways, moral of the story is the one that is higher gets oxidized. The one that is lower gets reduced. And then there's one more thing that table J can tell you that you need to know is it'll tell you if a reaction will actually occur spontaneously, meaning on its own. Like, will it just up and happen or not? So the rule is, let me show you an example. Okay, so the rule is you have this lone thing right here, this CS, that wants to react with this couple, and it wants to do a single replacement where it like kicks the Mg out and it switches places with it. So now it's CS is with its girlfriend Cl and Mg is alone. Okay, so when you're looking at a single replacement reaction, the lone one that's going to do the kicking out must be like stronger to actually kick that guy out of the couple. So the reaction will only happen like naturally, spontaneously on its own if the lone one is higher than the couple one. All right. So if it is, you'll go, okay, yep, that'll happen spontaneously. If it's not, you'd say no reaction. It will not happen on its own. So let's try that. Okay, will this single replacement reaction right here happen on its own? Is the lone, the guy that's alone, stronger than, and it's always, this is a metal, so it's going to replace the metal. Is the lone stronger than the metal in the pair? So let's find CS and Mg on our chart. So there is CS and I just saw Mg. Mg. Okay, so CS is higher. Is that what we wanted? So, yep, CS is higher. So this is higher than Mg. So we go, okay, the lone guy, the one that's alone, is higher than the one in the couple. So it can go ahead and kick it out. So this will happen spontaneously. So that is why this will happen spontaneously. That's why I highlighted this green, because it said which will occur spontaneously. So that one would. Let's try the next one. Mg is now the lone guy. Let's do a different color. Mg is alone. CS is the metal in the couple. Mg is looking to kick CS out of the couple. So is the lone guy stronger, higher on the table, more active, or more reactive? Is Mg higher than CS? If we look here, no, it's not. Mg is lower. So it really wouldn't be able to kick CS out of the compound. It's not as, I keep saying stronger, but it's really just not as reactive. So what we would write for this is no, just like it says, but I think this got cut off. No reaction. That reaction would not happen. All right. So there's two things you can use table J for here. One is the higher guy gets oxidized, the lower one gets reduced. And the other thing is, will a reaction happen spontaneously? Yes, if the lone guy is higher than the one in the couple. No, if the lone guy is not higher than the one in the couple. So just think of it as having to be higher to like kick that one out. All right, so let's do the other thing you have to know is which gets oxidized and which gets reduced. Oops, I didn't mean to cross it off. We pick another color. All right, so if I look at this reaction, who gets oxidized, who gets reduced? First of all, will this reaction even happen? So let me look. Fe is the lone guy. Is he stronger? So this is a metal, so it's going to replace a metal. It's not going to replace a non-metal. So I'm like, is this lone metal stronger than the couple metal? Is Fe higher than Li? Well, Li is right at the top, so that's not a good sign for Fe. Fe is down here. So, okay, so the lone guy is not higher than the guy in the couple, so this reaction is not going to happen. So I would write no reaction. All right, let's try one where it does happen and determine who got oxidized and who got reduced. So I want to figure out who got oxidized, who got reduced. So remember, the thing, will the reaction happen is the lone guy higher than the couple guy? The who got oxidized, who got reduced, the higher one gets oxidized. So you could think like, oh, O comes before R in the alphabet. So the higher one gets oxidized, the lower one gets reduced. Or you could think it goes oil, rig, O, then R. Or you can think of it as the rich, oxidation is loss. The rich, higher one gives electrons down to the poor, lower one. However you want to remember it, oxidized, reduced. So let's see. Fe and Li are two metals. We are going to ignore our non-metal here because we're just talking about metals. So Fe and Li, who gets oxidized, who gets reduced? All right, Fe and Li, Fe and Li. Let me pick a different color. Fe and, oh, there's Li again. Okay, so Li is higher, and we said the higher one gets oxidized, the lower one gets reduced. Right, so higher one gets oxidized, lower one gets reduced. So that is my answer here. The higher one gets oxidized and the lower one got reduced. So I highlighted this red to show that it gets reduced and green to show that it gets oxidized. So that is what you'll have to do in your homework today. Two things. Who gets oxidized, who gets reduced? The higher one gets oxidized, the lower one gets reduced. The other thing, will a reaction spontaneously occur? Yes, if the loner is higher than the one in a couple. Let's try an example. It's asking me all these questions about this cell that I learned. So I could go, okay, well, I have silver and nickel. So I can say, well, if I can figure out from table J who got oxidized, who got reduced, then I can use like anox and red cat to figure out where the anode and where the cathode is. And then if I know anode and cathode, I know who's positive and who's negative. And then I know which way the electrons flow. So let me use table J to get this started, and then I'm going to have a lot of answers just from that one thing. So Ag and Ni, remember the higher one gets oxidized. So Ag and Ni, where are you, Ag and Ni? So Ag, I always remember that silver is really low. And then Ni. So it looks like Ni is higher. The higher one gets oxidized. All right, so I'll just write that on here. The higher one gets oxidized, the lower one gets reduced. And now just with that little piece of information from table J, I can figure out a whole bunch of stuff with my memory tricks. There's also a little part down here where I could have figured it out. A lot of these problems have like this little equation down here with charges. So if I didn't want to use table J, I could go, okay, Ag was positive, and now it's a 0 alone, so it went down, so it got reduced down. Yep, so Ag got reduced down. Ni went from being alone, a 0, up to +2. Okay, so Ni went up. Okay, so Ni got oxidized. All right, so you can use table J or you can use the charges like we've learned. Either way is a good way to figure out who got oxidized, who got reduced. And now that I figured that out, before I even answer these questions over on the side, I'm just going to write all the other stuff that tells me. Because I'm like, okay, red cat. Okay, this is the cathode. All right. Anox. Okay, this is the anode. All right, well, the cathode with the T in it, or I love cats, is the positive one. Anode is the negative one. Electrons flow alphabetically from anode to cathode, or alphabetically from oxidized to reduced. So just from using table J or the equation, I can figure out who got oxidized reduced. I can figure out all these other things as long as I know my memory tricks. All right, so the first question here says, draw an arrow to show which way the electrons are flowing. So now that I know oxidized, reduced, anode, and cathode, I know that they go this way, from oxidized to reduced or anode to cathode. Done. Which is the negative electrode? Oh, I figured out this is oxidized, therefore it's the anode, therefore it's the negative. So Ni. All right, so lots of stuff you can figure out, and it's kind of good to like write it on the table. Or the picture. Which is the positive electrode? Oh, I figured out this is reduced. Red cat means it's the cathode. Cathode means it's the positive one. Okay, Ag is the positive one. At which or in which half cell does reduction occur? Let's see, I figured that. It was lower on table J and its charge went down, so it was Ag. At which or in which half cell does oxidation occur? I figured out that was nickel because it was higher on table J and because its charge down here went up. So either one is a good way to figure it out. Which is the cathode? Ag, because I figured it got reduced. Red cat means the reduced one's the cathode. Which is the anode? Well, I knew this got oxidized, so I went anox. That's the anode, so it is nickel. So you can figure out one thing and then use your memory tricks, you can figure out the rest.